Let us begin with the first type of bond that is formed when there is complete electron transfer from one atom to another. This type of bond is known as ionic bond. By definition, ionic bonding is electrovalent bonding that involves complete transfer of electrons from one atom to another. Now let me take you back to the first topic. Remember ion formation? For example, sodium ion formation is part of the process that takes place in the formation of sodium chloride. Let us remind ourselves how sodium ion was formed. First, a sodium ion that has 3 energy levels and electron arrangement of 2, 8, 1 loses an electron in order to form sodium ion that has a positive charge. I'm sure you remember how to calculate the charges. This kind of change is represented by the following equation, where sodium forms a sodium ion by losing an electron. Next, we have chloride ion formation. Since sodium chloride has both sodium and chlorine, so let us see how chloride ion forms. There is gain of an electron to form sodium ion with a negative charge. Have you ever wondered, where does the electron that chlorine gains come from? Of course, if you have guessed that it comes from another atom, you are correct. So let us see how sodium loses an electron to chlorine to make sodium chloride. So when you have sodium atom, it loses 1 electron through electron transfer, whereby I want you to focus your attention on this location here and this location here. The electron now transfers, it moves to chlorine. Now sodium does not have any electron in the outermost energy level, and therefore we do not need to draw it. Now you remember how to calculate the charges and write the resultant ions. So for this case, we'll write sodium chloride as follows. Notice that chlorine has gained 1 electron to form chloride ion that is negatively charged. Sodium lost 1 electron to chlorine to form an ion that is positively charged. Now, from our previous knowledge, we know that opposite charges attract. So the positively charged sodium ion is attracted strongly to the negatively charged chlorine ion to form sodium chloride as one compound and not 2 separate ions, but they are combined to form one compound. This is represented by the following equation, where sodium ions are combined with chloride ions to form sodium chloride. Let us use another example of the formation of magnesium fluoride. We'll start with the ion formation of magnesium. Magnesium loses 2 electrons to form magnesium ion. And we have the equation here. we have the charge as 2 plus because it has lost 2 electrons, and from our memory we can calculate the number of electrons lost and the charge of the resultant ion. Next we have the fluoride ion formation. Fluorine gains 1 electron, and so just like sodium and chlorine, magnesium and fluorine would also have a complete electron transfer. Now let us see how this happens. Magnesium loses the 2 electrons in its outermost energy level, while fluorine can only gain 1. Therefore, we'll require 2 fluorine atoms so that each of these electrons could be transferred to 1 fluorine atom. This is how it happens. There is complete electron transfer from magnesium to fluorine. Now, once the electron is transferred, the next electron is transferred to the second fluorine atom. In the end, magnesium does not have any electrons in the outermost shell, and therefore we do not need to draw it. Finally, we have the complete magnesium fluoride formula or structure drawn here. Remember, these 2 represents the number of ions after the number 2, which means fluorine ions are 2. And that is why in the formula we write MgF2, meaning 2 fluoride ions combined with 1 magnesium ion. As for the equation, we have it as follows. And as you can remember, this rule of how to write magnesium fluoride applies with the valency. So the valency is actually derived from this concept of ion formation. Generally, ionic bonds form between metals and nonmetals. Here are some examples. Sodium is a metal. Oxygen is a nonmetal. So sodium ion, oxide ion. This one is an metal. They form an ionic compound known as sodium oxide. Next we have aluminium and chlorine. As you can see, aluminium loses 3 electrons, but each chlorine atom can only gain 1. Therefore, we need 3 chloride ions, and therefore that's why the formula is written as AlCl3, also related to the valencies. Next we have is magnesium and nitrogen, or nitride ion. We'll require 3 magnesium ions to combine with 2 nitride ions to form magnesium nitride. Try to figure out how we balance the number of electrons that are transferred. Remember, the number of electrons that are transferred from one atom to another must always balance by adding or reducing the number of atoms in formation of the ions. Also, ionic bonds can form between metals and radicals. A radical such as sulfate radical. So sodium and sulfate radical combine to form sodium sulfate. Similarly, aluminium can combine with nitrate radical to form aluminium nitrate. Magnesium can combine with a phosphate radical to form magnesium phosphate.